When we talk about relations versus functions, we're talking about it like we're talking about numbers in the real number system. When we're comparing natural numbers to, let's say, rational numbers, we're saying all natural numbers are contained inside of rational numbers. It's kind of the same relationship here. All functions, every single function, is a relation. This is the big group of things. The relation is the big group. The functions is a very specific type of relation. A relation is just any set of ordered pairs. So it's really just sets of numbers, an x and y combination. These are two examples. They're really ordinary. There's nothing special about them. Each of them has a domain and a range. The domain is a set of all first numbers in the ordered pair, all of the x values, while the range is a set of all y values, all of the second numbers in the ordered pair. So when we're listing out the domain from this just random set of numbers, this relation, we're going to list out the domain as all of the x values. We're just going to pick out the x values from each of these coordinates, -1, -3, 6, 2, 0, and 4. It's all of the x values listed. You could list them in order if you want. You really don't have to. When we list the range, we're just listing out the y values. Again, you could list them in order. We're just listing out the second number from each of these pairs of numbers, just the y value. Kind of the same thing when we're looking at a graph. We're really just going to list out the x values. This is a little bit tougher because we really have to look at the coordinates first. So I'm going to look at all of these coordinates. A is at 5 and then up 4. So that's at 5, 4. B is over 6 and then down 1. That's 6, -1. C is over 1, down 3. That's 1, -3. D is over to the left 5, that's -5, and down 1, that's -1, and then to the left 2, and up 6, that's where E is. To the left 2 is -2, and then up 6 is +6. So then we're going to really just take these coordinates. We're going to take the domain, all of the x values, and list them out, and we're going to take the range, all of the y values, and list those too. More often than not, you're really going to be asked to use the domain or the range, especially the domain. They'll give you a list of domain, and they'll say, plug these x values in and find the range. They're telling you to use the domain to find the range, plug in all of those x values, and that'll help you find the range. That's with equations. Usually they won't give you a graph for this. So in addition to a graph, like we just saw, and just a list of ordered pairs, and a graph, those are the two that we've just seen. We could also see this written as a table, or we could see it written as a mapping. We'll talk about what a mapping is. It's basically a table. You're going to use the points that they give us, the relation here, to show that relation as a graph. Really, you're just plotting all of these points. We just want to see what that looks like on the graph. So plot those on your own, and then pick back up with the next example. We've also seen a relation as a table. Actually, you should be able to do this on your own also. You're going to take all the x values and list them out. You're going to take all the y values, the range, and list those out. And you're just going to make sure that the paired ones in the ordered pairs are matched up left to right in these rows. All right, mappings is the new one that I have to show you. That's basically a table, except instead of having all of our points lined up, we're going to have arrows representing that those 2 points are connected. All the x coordinates are going to be on the left, just like a table. All the y coordinates are on the right. We're going to just draw an arrow from matching points. So from -1 to 3 for this first set of coordinates. From -1 to 3. Now we're going to connect the second set, that's -3, going to 5, that's the x value of -3, matching up with the y value of +5. You should be able to connect the rest on your own. So a function is really what we wanted to get to. A function is a set of ordered pairs, so it's a specific type of relation with ordered pairs that each element of the domain has only one element associated with it in the range. That is a really tricky sentence to get through. We'll come up with a couple easy ways to test that. It's just saying that for every x value, there's only one y value that goes to. Alright, so we'll talk more about that though. The first thing I want to talk about, again, that this is very related to the real number system. So when we look at this graph, it's the same kind of relationship as this. Functions are nested inside of relations. Every single function is a relation. Not all relations are functions. There's random relations that don't serve as functions. Just like there's random rational numbers that are not natural numbers. There's no natural number that can possibly escape being a rational number, because rational number is the bubble that contains our natural numbers. Another way to say this is that every function is a relation, but not every relation is a function. So now more back to the definition of a function, what it means to be a function. A relation may have y values repeat, but it may not have x values repeat. And in a mapping, that'll look like this. It's going from 1 to 8, 2 to 8, 3 to 8. The y value can repeat. Y can be 8 for all of these x's, but we can't have the opposite. 2 can't go to each of these. 2 can't go to 9, and to 8, and to 0. And the real reason behind that is because a function really means that it has a purpose. That's what that means. It's saying there's a rule that's taking 2 to 9. Let's say we're adding 7 to it. Let's say it's the rule x plus 7. That takes it to 9. We don't want that rule all of a sudden changing and taking it to 8 or taking it to 0. Then it's not a rule at all. It's not serving any sort of function. It has to follow a rule for it to be a function. Basically, any input that we put in, it's got to come out the same thing every time. We don't want it changing up whenever it wants. Alright, so now we're going to try to distinguish between functions and relations. We're really just looking for those repeating x values with different y values. So on the first one, we're looking at just the x value really. -1, -4, 1, 8. Those are all different. That has to be a function. I'm going to circle that. That is a function. All of the x values are different. On the next one, we have 3, then 13, then 3 again, and I see that 3 is going to 1, and here 3 is going to 7. That can't be a rule. There can't be something that takes 3 to 1 and 3 to 7 at the same time. So that is not a function. The last one, we have 1, 9, 4, 9, 6, 9, 0, 9, and -5, 9. And you might be thinking, what rule could possibly take all of those to 9? Well, the rule where y equals 9. It doesn't matter what x equals. We could have the equation y equals 9, where y is just always 9. It doesn't really matter what x is. It doesn't really matter what the input is. You will always get 9 when you plug it in. That actually is a function. Alright, now down to the mappings and tables. We're really looking for an x value to have two different y values. So this x value is repeating because we have two lines coming out of it. -3 goes to 77, and it goes to 13. That can't happen. And that is not a function. Alright, on the next one we have repeating x values here. We have 3 and 1, and 3 and 10. That one can't be a function either. And on the last one, our x values are all different. -6, 87, 31, and -10. Our y values are the same, but that's okay. That is a function just judging based off the x values, because again, we're just looking for the same input to go to a different output. I think the easiest way to still tell if something's a function is using the vertical line test. Even though this involves graphing, which kind of takes a little bit of time, the vertical line test is the easiest because it's just very visual. You really just graph the points and imagine a vertical line passing over the whole graph. If the line hits 2 points at any time, so I'm imagining this line just pass across, here it's hitting 1, 2, 3 points, that means it's failing the vertical line test, and this is not a function. Since we have overlapping points, we have the same x value here with a bunch of different y values. This is, let's say x is 4 here. We have a y value of -2, of +3, and +4. That can't happen. Alright, so we have overlapping points on our graph. That shows that that is not a function. So you're going to just imagine a vertical line passing over the entire graph. If it hits multiple points, there it seems okay, there it seems okay, there it's okay, there it's okay, and there it's okay. That means that is a function. That one's okay. Alright, I'm going to do the same thing with this next one to the right. Passing over each point, making sure that they're not overlapping. Here we see at the end, those two are overlapping with that vertical line. That's failing the vertical line test. That one is not a function. And you can see it on the next two. Here, you're passing that vertical line over that. It looks like it might at some point, but that one looks okay. That passes over the entire thing without hitting 2 points. This one is obviously going to hit multiple points. Here we see that it hits 1, 2, 3, 4 points. So the one on the left is a function, and the one on the right is not a function.